Hello, welcome to Live Coding with Gerph. If you've not been along to these before, this is where I code some random bits of a disassembler at the moment and try and make something that works for RISC OS. And it's been going really well. Well, pretty well anyway. We've had a lot of changes to the code over the past, what are we on? This is 16, isn't it? Yeah, 15 weeks worth of work. It's quite a while, really. Didn't think it would take this long. Admittedly, the basic version was up and running pretty quickly, but it's been mostly tidying things up since then and doing other bits. Plus, this hasn't been especially great in terms of how I would normally do things, because there's been a bit of just fixing things up in various places. So little bits of interest in things we've been doing there. Right, so where are we up to? So last week was a cleanup week, and I was changing, excuse me, at the end of the week, end of the session, I was adding in the necessary code for testing, which I'd stolen from another module that I'd been working on, message trans. And it was working fine in message trans, but when I came to do it here, it wasn't very useful. It was really unuseful, in fact. So that was frustrating, and I tried coding a bunch of it, and it ended up coding a lot in Bash, and I gave up on that. At the very end, it was about a quarter of an hour I'd run over. So I left that and did it all offline. So the work I was doing was largely updating shell scripts. So here's the code we've been looking at. Not that one. This one, run on build service. So this is the actual code that does the actual running of things. So the idea is we have test script here. This test script just includes two other test scripts. One that is testing the debugger when it goes and describes which tests we're wanting to run. Excuse me. And then it goes and executes these tests on our build service, the build service I created, which is a RISC OS that runs in the cloud, which executes the code and then returns the results to me. So here we can see we try and the test here is called show regs with no exception. It tries to run show regs. We expect this output, show regs none, and then we do some replacements on it. And we always do replacements on things to get rid of those odd little differences between one run to the next, like where the memory is. So if something loads in a different place, or if for example, difference between running it in RISC OS Pyromaniac and running it in RISC OS Classic, or, as we're doing here, running one version of Debugger against my new version, which will have different outputs and be slightly different. Some of which will matter, some of which won't. And that's what we're trying to compare. So we get results out that tell us what's going on. So this is the very first test that will be run. It's called show regs with no exception. This is the magic that does it. I'm not going to go through all of that, but essentially it repeats going through the command line, works out what you asked it to do, and then builds up a build command that can then go and execute that, which has a set of things on it. So each command that gets executed gets sent to the server, executed, and returns. And so we get to see what happens. And the output from that, I'll scroll up here. This is a run I did just a few minutes ago. Looks like this. So this is the test we were just talking about, show regs with no exception. So this is when no exception is run, and it tells us we ran the script run on build service. We told it quiet, which means don't tell me anything about the build service messages, and just run this command, show regs. Now, it doesn't just run this command. What we actually also do is we also load the debugger as well, because if we didn't load the debugger, we wouldn't be testing our code. But we go and that's all lighted into the build service command. And then it tells us the expected output did not match. So what it generated was not the same as what we got back. So what we generated is the things in the plus sections. It prints out all of the changes with a diff showing you what's changed. So this is what was printed out, and this is what we were expecting. The message was exception dump information for ARM stored at this address, exception dump is empty. And that's what RISC OS Pyromaniac produces, which is different to what we're producing in this module. So I've got two choices. I can either make it match RISC OS Pyromaniac, or I can make the differences, just make those not appear, so it doesn't matter. Because the information that RISC OS Pyromaniac generates is actually slightly more useful and actually closer to what RISC OS Classic does, I think I'm going to update it so it looks more like that. That's what I'm going to do. So I'm going to go through today and try and match up the changes that are the things that have happened. One of the things, if I just have to go back to the script here, so you can see here there's a test that says show regs after a branch through zero. So this is where we cause an exception and then we go and print out the message. Currently, you can't simulate that on the current environment because as soon as you generate an exception, it'll crash and return back to you to say, I've crashed. We need to work out a way of doing that. I will work that out offline because that's just something that's going to have to be made to work anyway. But generally, you wouldn't need to do that. You wouldn't need to generate a crash to see that you handle it properly. Well, you might do, but in this instance, you wouldn't normally be doing that sort of thing. So, excuse me. These ones are all marked as disable, no binary yet, which is because this binary doesn't exist, and we don't support it at the moment. So these are all the ones that were done there. There's also some other ones here that, again, we don't do. And then we go into some other tests. And it just steps through printing out. We're skipping this because there's no binary present. And then we get on to this one here. So it's doing this one. And you can see here there's differences. And the differences are largely these bits here. You can just see there's E in lowercase or E in uppercase. Also, if you have a look at the text output, it looks like in the Pyromaniac version, we don't output top bit set characters. So this is the non ASCII characters. We don't output them. So we can probably go and just hide that and make it look exactly the same. Whether that's right or not, we can argue that in the future. But for now, I think we can make that match, which will be the goal of this. So, as I say, this is a test run that I did earlier, just a few minutes ago. They take a little while to run, and there's quite a lot of output because we've got a lot of test failures. Most of them, see, this one's actually generated some extra output here, and it's got slightly different alignments. So that one, we're going to have to decide what we're doing with that. I'll worry about that one later. But a lot of them are just letters, the casing and the dump output, and that will fix a lot of things. A lot here coming at the same. This one is a extra parameter supply at the end of star memory. That's interesting. Apparently we don't care, and RISC OS Pyromaniac reports an error. Fair enough, we can fix that one. These are more interesting though. So this is where we did actually running memory I to disassemble things, and if you have a look at this, it's actually printed so we're printing the value first and then the hex values, whereas RISC OS Pyromaniac is printing the text values and then the number, which is interesting because I don't know which one RISC OS Classic did. I'm not sure. So I'm going to have to find that one out. We're going to have to check. Also, RISC OS Pyromaniac outputs all of this extra information about the module state, what type of data it is, which we're not going to worry about right now. We can actually strip that out and make that not get displayed and things. But that will be something we'll have to have a look at shortly. Yeah, so that's come out okay. Scroll down. There's some bits here. Oh, that one shouldn't have been run. Interesting. Yeah, so that doesn't have a binary, so we need to fix that one. Memory I register relative. Yeah, we can't run that one. Register relative. That should have been this one, memory, has been disabled, but I haven't disabled the memory I version. No input support. There we go. So that'll disable that message. This one. So this is all the disassemble flags ones, all the Debugger Plus implementation that we don't currently support. So I will probably just mark those ones as not needed. Memory I for thumb. Oh, we need the debugger thumb code. I can add that one in because we want to be able to disassemble that. And a hello world. Okay, we can add that in as well. Some more differences of case and the top bit set characters. And then some slight differences in case for LSL and LSR, which is interesting. Okay. All looking pretty good. There's some slight differences in the alignment of things here, so we might have to tweak that just to tidy it up, but the actual values we can say are okay. Anything else of interest in here? No, I think these are interesting. So this is, we're using the higher than or same and lower rather than the carry set and carry clear. Those actually mean exactly the same thing, but it's how they're represented that is slightly different. We can fix that one as well. So some of these are going to be easy, some of these are going to be a bit harder, but we'll have a look at it. We'll have a see what we can do. If I scroll right to the end, all the way to the end, we can see that we've got nothing passing at the moment. Because, yeah, we've got it's very different. Well, sorry, some bits are very different. So, what should we start with? We'll start with the first one, I reckon. I think that's a good place to start. This one here during show regs looks like a good place to start. So, can we run just one command? Probably. Let's have a see how we do this. I can't remember how I do this, so what it suggests in the output here is that we run on build service with quiet command show regs. So let's copy that. Oops, copy just that bit. That's the command I should be running. And if we run run on build service, I've got an example there. Just run that one command. Come on. There we go. And that's the output we get. All right. So that's telling us that it's working, basically. It is actually generating what it told us it was generating, which is good. So in addition, if we have a look in the test the test code expect directory in here, there's got a whole bunch of things, a bunch of the files that are output, and after them there's a bunch of actual. So if we have a show the regs actual, that was what was actually output, and this is what we expected. So we can find the relevant bit. Hello people, Rayan and Rowan. And David as well. Hello. So what we're going to be doing is fixing up the output to look more like this than this. So that's the output from the show regs command. Let's have a look what we've got in here. This is show regs. So no dump present is what it's sending there. And we want to send something like this. We can do that. That's actually quite simple. So let's do. I wonder why we've done Rightland, not printf. Probably just laziness. When I was writing this, I was probably thinking I won't use printf. I'll just make it use the other bits. Let's actually use printf because why not? Printf. exception information for ARM. Well, actually, yes, we need to decide what platform we're on, don't we? How do we get the platform name? I want to print out the platform name there, not the architecture name, and this here should be the RISC, the address. Let's do that. Ivar has asked, have you ever tried vibe coding? No, I have not. It feels like you're not really learning as much about the system as you're expected to. It might work very well for some people, but I haven't tried it. Maybe at some point I'll give it a whirl, but at the moment I haven't tried that. It's not a thing that I have yet tried to do. On the other hand, I have tried generating code, just telling AI, make me this. Oh, that's wrong. Do it this. Oh, you got this wrong. Do this. As a couple of little small things, and that gave me something that was still broken, but then I fixed that up and it was fine. I've done it once. It was quite impressive, but in RISC OS there just aren't a lot of examples around, so I don't think it will do so well. But that's just me. We'll have a look in the future. Right. What have we got here? This is what I want to do, is I want to print out the address of the register dump, which is reg dump. There we go. And then this is actually printed out all the time, this one, isn't it? We always print this one out. So let's put that up here. Exception dump for arc name there. And then this one, we can just change the message in this right one to exception dump is empty. Okay. All right. So what I need to do now is to get out the architecture name. If I remember rightly, the architecture name isn't decoded when we do describe CPU registers. Because I think default CPU registers, yeah, it just tells you a bunch of data, not what the architecture is. To get the architecture, I think you have to go and know these things. Do I get that information in your introspection? Introspection, that doesn't generate it. That's not very helpful. RODIS, do we have anything in RODIS that knows about the architecture? Doesn't look like it. Not sure where we would have got it. CLI parser. Here we go. Oh, but that doesn't actually decode the name. Well, that isn't very helpful. Yeah, we decode the other way, but not there. All right, just for simplicity, I'm going to just build it directly into that code because I might as well. Actually, we know what architecture we're on. We know what architecture we're on because we've compiled for it. If def RISC OS 64 line arc name ARM, no, ARC 64, else ARM. There we go. That was. I don't need to work out dynamically what we already know. So, in which case we can actually embed this directly into the string and make it a little bit more efficient. Arc name, there, and then the register dump address. Okay, let's go and try running that. Oh, we've got to build it first, haven't we? So let's build it first. RISC OS ammo file. Oh no, I need to be in the go up a directory. Build makefile module, and then come back here. Yeah, that looks good. build it. Inventing printf. All right, well, let's just go and include printf. I mean, we're already including lots of other things, so it's not going to matter that we're doing that. I think we're already using printf elsewhere. Right, the warning's gone. Good. Now we can try running it. And this takes a little bit longer because we have to throw it all the way to the build server. And that's because I also need to copy the file Debugger to here so that it can actually test it. Not quite as nice as a test that as I'd like, but at least we can do this. Right. Why is that doing odd new lines? I know why that is. I do know why that is. Come on, why was that? Oh, it's because it's literal output. Is that right? Or is it because we turn off the TTY? I think it might be because we turn off the TTY. Let me have a look at the code again. Let's see. I mean, it's not like it's a big deal. It's just A off. If I turn that on, does that make it come out normally? So Ryan suggested, if you run it a lot, why not use an alias? It's a very good question, but a lot of the time I don't tend to use aliases because I can just press up a couple of times, or it's something about using fish because I just press that in, or if I wanted to find it, I just type show regs and press up, and it finds me the last command that I'd used that in. I can keep going back until I find one of the ones that I want. So I don't tend to need to do that. So at the moment it's just 2 ups, return, 2 ups, return. And that sort of helps me. Right, so in any case, these /r's are not coming out right. Is that going to matter? Do I care? I mean, as long as the test comes out all right, it doesn't matter really. Let's see what the test produces, shall we? So I run the full test, so make tests here. So just see what this generates. Okay, so we can stop that test from running now. Stop magic test, stop. And the difference is, right, I've got a different address there. Yeah, fair enough. And I've missed a new line, but the extra new lines that are coming out there are not different. The reason it's coming out different is one of the parts of the system thinks it's running under a TTY and the other one doesn't. And so it's running things in different ways. It's just outputting /n. So that's what's going on. I don't think I'm going to worry about it too much because I can see what's going on. Except that's not going to be true when I'm outputting pages of this. Is this sed doing the wrong thing? Is that part of it? I think that sed might be part of it. If I take that away and run it there, what do we get now? Oh, we got multiple /r's. That doesn't look right. Stop. Stop, please. Thank you. Yeah, my harness is not quite right at the moment, I'm guessing. What I could do is replace the double /r with just /r. And that would help, I think. And if we run that manually here, I think that would come out right. Yeah, that's coming out with the right line endings. That's good. Okay. Except it is different because it's got only one new line in it. I want an extra new line there to make it look the same. Okay, here please. Oh, I didn't build it. Stop. Build, thank you. Build, run. Earlier this week, well, most of this week, I've been writing code in Python, so building things is not a thing I do. Right, so there's a slight difference here in that it's using a different area of memory for the exception dump. And does that matter? Probably not. But we don't actually change this. So I'm going to leave that as it is, and we'll just not worry about that one. Right. Next one here is memory. So can I tell it to run just one command? That would be really nice, wouldn't it? If I could tell it just to run one test. Wonder how I do that. So test.pl, I think there's a way of saying just run a single test. Oh, I've actually got help in this, that's fine. So script to run test and regular expression. Okay, so I could do minus test regular expression would do that. So I want to put that into the make file. Test args if test. If we don't specify a test, then test args is nothing. Otherwise, test args is minus test. Is it minus test or minus minus? Just minus test. Minus test, and then the test name. Like that. Put quotes around it. Oops, quotes around it. Right. Oh, not fee, it's endif in here. And then we can do test args there. Probably should put those. Oh, that's interesting. It's actually able to use minus or minus minus. Okay, well, we use the double minus form. I clearly was being lazy when I wrote that. Okay, so now if I do make tests, test equals, I don't know what the test should be. What was it called? It was called star memory. Okay. Up star memory. Is that going to work? Let's have a see. Let's have a see. Hey, it has. It's running just that one test. I'm quite pleased with that. That's done the right thing. Except it's hung. Oh no, there it hasn't hung. Apparently the dollar thing didn't work. It's running some other ones, but no problem. Oh, and it's still getting this /r on it. That's frustrating. I need to find a way of identifying whether I'm running a command line or not. If we've got a TTY, we're running a command line. Yeah. If we are at a TTY, then oops, no, actually square brackets around it. If we're at a TTY, tidy output. This is so. Come on, cut that. Put tidy output there. If we're at a TTY, do it one way. Else end if. So, if we're at a TTY, we want to do replace all /r's with just /r. If we're not at a TTY, we want to just get rid of the /r's entirely. Okay. Oops, still running things. Stop, stop. Apparently that dollar didn't work. Let's escape it and see if it does the right thing there. Oh no, it doesn't like that. Double slash? Triple? Doesn't like any of those things. Well, I can just kill it every time I'm running it. I'll have to work out what the regular expression syntax should be when it's passing through all of these many layers. So, if I've got the new escaping in, does that work? Come on. No, it does not. No, it does not. Still got a /r on the end of it. Stop, stop, stop. And if I run it by hand, do we have it coming out right? Comes out right when it's here, but not when it's there. All right. I just do that. It's no longer a TTY. Come on, work. Right, okay, so we've lost the /r's at the end. That's good. So now the only differences we're seeing are real differences. Stop it from doing things. Go away. Thank you. Right, and the differences are capitalization and top bit set. But what I should do now is stop and commit the code that I've changed, because we've changed some bits of it and it's obviously in need of doing things. Right. Okay, yeah, so okay, well, I don't know why I got that slightly different, but that's okay. All right, just pull auto stash, please. Just check that I haven't got anything set upstream. Yeah, there wasn't anything that I'd pushed that I'd forgotten about. Okay, I'm going to do multiple commits here, so I'm going to go and do it through Sublime Merge and just commit individual sections. So start out with the tool changes here. So this is update tests with things that aren't relevant. So git commit, update the test definitions to remove Pyromaniac specific things, specific options of coloring and input are not supported here, so disable. Okay, that's those done. This bit was ensure the test harness does not output /r necessarily. Should print as expected, and when printed in the tests, we should strip the /r's. What else do we have here? Oh, let's go back. Oh yes, this bit here. Actually, I want to just edit that slightly. I just realised if I go and put in into the make file the taking input from dev null, I won't have to type it. And that will make things easier for me. So back to Sublime Merge. It's not that one, it's this one. Yeah, so this section just a single test with tests, test equals not a single test, a set of tests. There we go. Right, and this one finally is the actual bug fix, which was update the show regs. Update our show regs to more closely match the Pyromaniac output. The exception dump and the, what else do we output? Wording is a little different. Expectations. And then we'll push that to the server. Okay. We can drop that out of the way now. Don't need that. And we can go and fix the next thing, which was the one we were just looking at, which I've forgotten already. This one here, yes, star memory. So this is the command here. Let's see if we can run that one manually. This command, there we go. Right, so this command is slightly different. So what we do is we load up into memory some random data, and then we try and display the contents of that data. And as you can see here, it is displaying it, which is good. But as we noted, the output is coming out differently. We've got these lowercase hex characters being used. That should be pretty easy to fix, because I think that's just in memory I, and it's part of the dump stuff. Here we go. And we just need to replace all of the lowercase x's with a capital X to make them capitalized. I wish all bugs were this easy. Some more here, yeah, there we go. One there. One there. And also, so if we go back to the output here, we can see that there's all the top bit set characters. So let's just include that as an option. Oops. If def show top bit characters. Oh no, if not, hide. We'll change it to hide top bit. Value is greater than 128. Value just put dot. There we go. And then we'll make sure that that's defined at the top of the file. Omit the okay, and we build it. RISC OS ammo, whatever command we last used. What are the random? So Ryan's asked, what are the random letters and symbols after the hex codes? So that's these ones here. So this is the contents of the memory, and this is the as hex, and this is the same thing printed as text output. So it's strictly printed as Latin 1. So the values here are E4 25 48 9A. So E4 is an A umlaut or diaeresis. The 25 is % 48 is a H, and OE ligature capitalized is 9E, and so on. And so it prints out all of those. If it was, for example, a text string, you'd then be able to read it and be able to see what the text was. So that would be more useful if you were dumping something that wasn't just random data. No problem. I said thank you. Right, so that's built. So now we can run the test again and see what the code produces. And fingers crossed, we have capital letters there, and all of the top bit set characters are now gone, which is cool. They're not. What's that? What's that? That is a euro symbol. Why is that euro symbol snuck its way through? How did you get through? DC or C2? C2 probably. Oh, it's 80. Hide top. Yeah, off by 1 error. Greater than or equal to 128. There we go. Everybody makes off by 1 errors. And run it again. Okay, that now looks better. If I now go and run the test, hopefully we'll be able to see that coming out sensibly. I don't need the taking input from now. That should just work. I've just had a message from Dave independently saying that he gets clicks and whistles if he's listening to it, the stream live, which is a little bit strange. He says if he's streaming live, he gets occasional clicks and repeats, and then it drops out of live and lags a bit. Does anybody else get issues with like that? I heard from somebody else that was happening as well. I've only been using streams on YouTube a little bit, so I don't really know how much that could be different. Oh, this is interesting. Stop. Thank you. Right. So interestingly, so this is the run of the test we just did, and it prints out 8000 through to 8FO, absolutely fine, no differences. And then it says we produce some extra output that wasn't in the expectation, which is odd. Just let me check. Right, so just for Dave's benefit, the stream status here says it's healthy. I'm not seeing any issues at the serving it, or the YouTube end, I think it is. I don't really know. I'm sorry, I don't know much about that one. Oh, Rowan said the camera corner box flickers sometimes, but he hasn't heard any audio issues. This is all quite exciting. I wonder if the flickering of the box is related to when I changed terminals. I'm not sure. It doesn't flicker. I don't see it flickering there. I might need to go and watch the videos back. I did watch the videos back before, but since I've added the new where is it, around here, this little blend at the edges here, that obviously has a little bit of extra CPU impact on things, so it might be that that's actually caused things to change. Oh, and now my camera's stalled. What the heck? It's like there's my, oh dear me. Let's see what we can do here. Let's just quickly pop over here. No, camera's stalled. I wonder if it's been stalled like that for ages and I've not noticed. Or maybe it just hates me. Let's see if we can turn the camera around. Ryan's asked about the software used for streaming. I'm using OBS for the streaming, which has been absolutely reliable for me, generally. There we go. Put it onto that and then go back to the presentation again. Camera's fixed. That's. I wonder if we can just how do I turn it off? Don't know. Let's try the harsh. Ooh. Ooh, I knocked the cable. And it's now gone. My camera's gone. Where's it gone? Properties. It's vanished. Let's disconnect it and reconnect it. Ooh, there we are. Right, camera's back again. Okay, okay. And we're back. In my excitement, I probably knocked the things, and it probably knocked a cable. I'm gonna say that was probably it. No idea what it was. See, professional YouTubers don't get this problem. They've got really cool things and what have you. I'm just playing at this stuff, so yeah. Right, where were we? I don't know where we were. Right, yes, I just done off by one error, and then we were looking at the output, and the output says we've got lots more. Oh, and then Dave was asking about whether the sound was breaking out for people. I used to work with Dave back when we were at RISC OS Limited, and I would be pulling at my hair. Clearly, it's had a bit of an effect over the years. I would literally be pulling my hair out. And I would come away with little bits. Oh dear, yes. I did tend to get a little bit distracted when I was working and do that. Yes. Although I can't remember if it was Dave that said suggested that I was pulling it and it was pulling my hair backwards, and that's why I was getting a widow's peak at the front. May have been my brother, I can't remember now, but it may have been Dave. Right. So we're outputting more stuff here. We've got all this extra. We're outputting about hex 180 larger than was expected. So that means that the default values that it's using are larger than the ones that I'm expecting. So where would I be putting that? Let's jump back to the code. It would probably be in the star memory parser. Oh, there, right there. Memory I default size, memory default size, 40. 40? So if we... I think it should be 16 lines, no, 16 rows. So let's give that a whirl. RISC OS ammo, that one. And then run the command again. And I think this should reduce it down to being just the bit we want. Right, that's looking much better. That looks like the output. So if we run make tests, we should now get a pass. Do we get a pass? Go on, give me a pass. Or you could just sit there and do nothing. Thank you! Woohoo! Yeah, okay. Let's see what the next command says. Ooh, that passed as well! These unaligned ones we don't support because we get slightly different output. Yeah, we output a full row instead of just the bit it wants. Unaligned size and unaligned base. Okay. Do we think we can make that work? Probably. Probably we can. So let's see what let's just stop it. Please, can you stop? Thank you. Do I need to commit anything? Yes, I need to commit things. This is fixing star memory. Fix for star memory producing lower case hex and overlong default output. Memory command was writing hex lower case when we expect uppercase. Now fixed. Sorry, and we were outputting 40 rows by default when the expectation should be 16 rows. Now fixed. Done. And let's push that as well. Okay. And the bit I was just looking at was, what were we looking at? Right, this is when we've got slight offsets. So we've got, when we do plus 20 it works. When we do plus 13 it fails. So we do plus 13 there. Is that right? Was that the command I wanted? 8,000 plus 13. Yeah. So we output a whole row when we should be outputting not the whole row. So let's have a see how we can do this. We will at least cut off the last two words from that. So let's have a look. Back into memory I. What's this bit here? if offset plus data width is greater than the data read, if we didn't read the data. Oh, so we're always reading a row size, even if we don't need enough. So to read equals row size. If end minus address is greater than, is less than to read, then this will give us just the amount that we actually want to read. Equals end minus address. But we've got to round that up to the data width length. So add on data width minus 1. There we go. And I think I'm missing a bracket down here somewhere. Yeah, that's right. So that should give us rounded up to a multiple of 4. So build that, build that, build that. There's the build, thank you. And then run it. I think that should come out about right. Nope, that did not work. Interesting, why did that not work? Firstly, did I change the wrong code? No, this should be the right code. Current address minus the end is less than the size we should be reading. Then read, let me left to print to read. Let's just make this into a variable so we've actually got a little bit more logic in there. So this, it should be that this is going to give us the right length, but I'm not. Oh, so if the data, so Dave's asked whether that gives us a multiple of 2. So what it should do is if the data width is 4, it'll add on 3 and then AND it off. Oh no, that'll round it down, won't it? I want to round it up. Oh no, I do want to round it down, don't I? I do want to round down, yeah. Well, that's what I was hoping anyway, so I'll have to see whether this works or not. Left to read. Oh, hang on. I didn't actually change the amount it was going to read. So it's fun bit manipulation, so we always get confused at these. That looks better. It's rounded it down, which is probably okay, I think. So I'm going to probably want to round it up actually and make sure that the other values have got zeros in them. Round up and ensure that the output data is 0. Memset data 0 size of data. So if we try printing something that's a bit bigger, it comes out okay. So somebody's asked, does the graphic on your shirt have a special meaning? So the cog is the logo for RISC OS. And 64 because I've produced a version of RISC OS that runs in 64-bit. I'm currently the only person who's got a version that runs in 64-bit. So on the back of the t-shirt, if I can turn around, if we can see it, I can't tell if you can see this because I can't see it at the time. It should say, been there, done that, got the t-shirt. Hopefully you can see that. If not, you can get the idea. So yes, it's a very sad t-shirt.
And you've got the mug to match.
Additionally, I've also got a mug with it on. Talia's just reminded me. And I'm wearing shorts. Yes, thank you. Yes, this is why I wasn't going to stand up. I got it this morning and went, oh, I'll wear my shorts. Nobody will be able to see them.
Oh no, that's what I gave you, wasn't it?
There's a thing on the wall that I can't get down easily, but there's also this as well, which is my keep calm and I will keep coding RISC OS my way, which Talia made me the original picture of. Little light box. It's fun. Thank you very much. I'm not sure it's stuck. It should be stuck down. Probably doesn't stay now.
I'll pop it on there. I'm not going to be responsible for it falling off.
You can call me very sad now. That's all very just fine. Yes, where was I? So I was trying to work out, yeah, so whether this would print out properly. Round it up. So we can't read more than, well, let's see what it does. I think this doesn't work still nonetheless. I think I've still got a problem with this. Oh, that smells nice. I can smell marshmallows. No, still not doing the right thing. And the reason for that is because although we've read so the size we want to read should be the size that's left, but the size we want to print should be the size that's left rounded. Okay, so let's just tweak that a little bit. Ensure that the output data is zeroed there if we would overrun. So that's all we're going to do. And then if data read no round up the amount we will not less than 2 read, less than row size. Should be row size there as well. Round up the amount that we will print. And that should be data read equals data read plus the width. I think that's right. Make and then run. I'm being embarrassed by my shorts now. This is terrible. No, that's too big. You've done it wrong again. Oh, yeah. Because I should have said to read equals left to read, because we can't read more than is left. Yeah, I think that's right. I've said I think that's right a number of times and it's not been right, so I don't know why anybody would trust me. It's rounding down. Why is it rounding down? No, because if data read, not left to read. Go on. I feel pretty dumb at the minute. I really should be doing this differently. Dave suggested this is reminding me of using driving OSGBPB. OSGBPB is an incredibly difficult call to actually use properly. I've just realised I've been getting it working and I hadn't noticed because I've asked for 30 plus 13, so that's 16 there. And then that's the extra 3, 1, 2, 3 coming up. So that has worked. That has done exactly what it should have done. If I run the test now, can we actually see it doing that? The GBPB is get bytes, put bytes, and when you're enumerating files or just trying to read things in general, it's really easy to get stupid off by one errors or get it to read the wrong thing. And I think I've just made it a little bit more complicated here than I probably ought to have done. But at the end of the day, it's all about getting... OD. Actually, I think my code is right and the expectation is wrong here. I think the expectation is wrong. So I think we can probably, probably say that I'm right and Pyromaniac's wrong here, which is nice. Right, at least for the top one. For these ones down here, we're looking at something very different. So this one's trying to change the configurations. This doesn't matter. This code isn't relevant. I should disable that one. Right, we fixed one test. We've got some more to have a look at. Let us have a see. Is the 13 in hex? It's confusing. Yes. So all of the addresses, all of the values that you pass to this by default are in hex. So 13. I should say 13 rather than 13. I'm sorry. Because all the values in hex. The idea is that if you then do, you want to print out 8,000 through to 8,040, you do 8,000 plus 40 rather than 8,000 plus 64. Just the way that Debugger has always, I think Debugger's always done that. Or was that an extension I did? Actually, I don't know. It might have been an extension I did. Well, I mean, you could always write it the other way around. You could write 8,000 plus 10 underscore 13, and that would just do 13 bytes. I agree it can be confusing, but that's just the way that is. Oh, my nose is itchy. I think it's a little bit of a sort of hay fevery thing. Not that I get much problem with that. Right. Okay, let's put that change in because we fixed another one of the tests. Status. But we've only fixed one of them. Fix one of our tests for start of memory dumps being, sorry, end of memory dumps being aligned. If the end is unaligned to a row boundary, we now print out the spaces to make the gap. that's pretty much it really. I mean, there's not a lot else I can say there. Okay, push that. So the next problem was if it's unaligned at the start. So if we start from where we're doing it here, we've got 8,000 plus 13, hex 13, 1, 3. So let's do that one. 5 plus 13. Oh, yes. No. So this is currently, I think, broken because I think we just start 8005. Yeah, we start 8005. So all of these values are now unaligned and it's not very helpful. So that we want to make it start at 8000 and print spaces up to the first word. How do we make it do that? How do we make it do that? I think I probably just need to remember that there's got to be a gap at the beginning and then print that out. I think that's what I need to do. Okay, let's try that. Address. So we have the address we're actually trying to print, and we have the address that we've read, which may be a little further on. So let's do uint 32 row start equals address. Oh, and we want to know if there's a gap as well. So if address and this is when we know we've got a gap. In fact, that is the gap. Gap is the offset there. No. Work out the number of words Dave just suggested he's been using memory I PC plus 16 minus minus 16 plus 32 and never checking how much got printed because it just printed something and that was what you wanted. Yeah, that probably is true, and yeah, not a big deal. Work out the number of bytes we need to skip for row start. Row start equals with that bit cleared. So that's where the row starts. And the gap is going to be that much. So we want to read into gap. If gap is not 0, clear the memory. Yes, that means we might end up clearing it twice, but I don't think it's going to matter performance-wise here. So we read it into gap, and then we want to print out the address at row start. If offs or offset is less than gap. This is hurting my head. I'm sure there must be a better way of doing this, but I'm going to go and just try it and see what happens. I think maybe there is. Oh, that's not what I wanted to do. I didn't want to run that one. I wanted to build it. Build code. Yeah, Rohan I think suggested earlier, or possibly Rayan, I can't remember. One of them suggested I should have an alias for this. That would probably help. In fact, because they suggested it, let's go and quickly copy this. Make file. Build. No, that's not going to work. Just going to need to turn that into a tab because it's not a tab at the moment. Get rid of that. Now it's a tab. Right, okay. Make build. There we go. And then we can run the test code. That's this one. Each individual test is going to be different, so. I think that's not right. I'm getting the feeling that that's not the right thing. Rowan's just corrected me that it was Rayan. I'm clearly confused by having people that have similar names. I mean, it's not unsurprising. We used to have like 4 Daves in one of the offices I used to work at. In fact, the last office I used to work at, there were 3 Justins. Well, 2 Justins plus me. I'm an ex-Justin. That didn't work. So, why didn't it work? It didn't work because... Oh, the gap needs to be divided by divided by data width, like that. That won't work because I haven't actually built the code. Make build. Ooh, that looks cool. It has moved it along, so it's printed it out for there, but it hasn't printed out the next bit, which is odd. Is that because address equals row start plus row size. I think that's more correct. Apparently that's not quite correct. What did I just, how did it, what? So you were working, now you're not, but now I'm getting the next line. Oh, it's printing out more things. I'm very confused now. What did I just do? So the change I just made was to do address plus equals row start, and that's divided by data width. So that's the first, but that shouldn't affect the second line. So put it back to how it was. That's good. This shouldn't be divided by data width because it's actually in, it is in bytes. We're adding on the data width. Ooh. Maybe that's all I need. I'm feeling very dumb at this point. Because a lot of this is like, make a change, see what happens, make a change, see what happens. Which is not the right way of coding. Well, it's actually fine for many things. It's just for this stuff, it should probably be less tinker with it and see what happens. That feels like it's done rather more than it should have done. Or it's hung. That printed out a lot of, oh dear, oh dear. That feels like I've got an uninitialized variable in there. Mem declared but not used, implicit narrowing cast. 339, no, that's not in there. Data width times 2. Amount of data read is less than row size minus gap. Actually, no, it shouldn't be minus gap, should it? So we read it into the right space. So we've got a data buffer, and we read it into that space. So the data read is that part. If the width is greater than the data read, we need the gap in there as well. No, that one. That's reading too much data there. That's why it's reading too much data and it's corrupting one of these registers. That's what's going on. And the reason for that is that the left to read is much too big. Left to read is correct. To read equals row size. So I'll change this to read because that's how much we want to read. And that should be the size that's after the gap. So, if gap is not equal to 0, to read equals row size minus the gap. Oops, didn't mean to press that. There we are. So now we know the gap before we start to work out how much we need to read, and that could be less than the entire memory. Left to read is that much. Okay, I think that's a little better. Could be broken, not sure. If this works, we'll take a break. If it doesn't work, we'll probably take a break anyway. Okay, so what we've got here is what I'm going to do is if we were to do the whole block, it would look like this. So this bit here is matching up, so that's good. That's matching, that's matching, that's matching. This isn't. In fact, that's it. That shouldn't have been printed, I don't think, because 15 plus 5 plus 1, 3 is 1, 8. Oh, plus 1, 8, it should give me 10 plus those 2. It should take me all the way to the end. Oh, so I've got the start working, but I've not got the end working yet. Okay. Okay, so with that in mind, I'm going to say, let's have a short break. That reset my head and I can look at this. Honestly, I think this is probably way overthinking what I need to do here, but I'm trying to make it consistent with how things were in Pyro's debugger. So I'm going to have a 10-minute-ish break on this. Might be a little longer, might be 15 minutes. But what have we got so far? It's a quick summary. We've got some testing that's now starting to work. And we've put capitalization in there. We've got some bits that are showing the right thing. Not everything's working fine, but at least we've got some of them working. We've got at least 3 OKs out of it. So we can start having a look at the remainder of the tests as we go. Honestly, this probably shouldn't be taking as long as it is. I should be probably doing this a little bit differently. But again, it doesn't matter because somebody can always come along and go, well, that was stupid. I'll do it this way instead. And then it'll work better. But right now, yeah, that's what we're up to. So, 10-minute break. Oh, we've also, very important, we've tinkered with the system to find out why camera was not working and chatted about the streaming things. So yeah, all right, back at about probably 2:45. So 2:45 I think that's going to be, isn't it? Hopefully. There we go. See you in a little bit. Hello again. Oh, we're back, and hopefully we'll be able to remember and work out what we were doing. Yes. So this was meant to. I was meant to be trying to get this whole block out, so we should be printing out these extra 8 bytes here, but it hasn't. It's decided that that's not printed, which is interesting. So what have we got here then? So if we have a look at this, the to read the gap will be 0 there, and so to read will be a row size. I know what I'm going to do. Print out some things. Row start. Sense X. Gap of that end. So to read equals X. Right, let's print just those ones out and see what we get. Row start gap to read. Make build. And then run it. Not that one, this one. Right. Row start was at 0, gap of 5. To read is B. B is 11. So 16 minus 5 is 11, that's correct. And then it thinks it only needs to read 8. Hang on, am I stupid here? 5 plus hex 13 is 18. No, I'm stupid. It shouldn't be printing this 0 out. It's read exactly what it should have done, and it shouldn't have printed that out. So it probably means an off by 1. Should that be greater than or equal to? Or probably should be greater than or equal to there. Go build that. That looks right. Okay, I can get rid of my debug now. Right, let's try this with, build it first. Right, 0 plus 1. I think 1 should probably print out something. If I do plus 4, I get 1. Plus 3. Nothing. But it does print out this the dots at the end. This section is working. That should have rounded it up. You know what I'm going to do? I'm going to put this down here and include data red as well. And this is probably the simplest of things to do, because it's literally how much am I needing to print out? And yes, I'm still having difficulties with it. Data read 4 bytes, which makes sense given that it's read 4 there. Gap is 0, to read is 3. Offset 0 plus data width is greater than data read, which no, that shouldn't be greater than or equal to. This data read should be, oh, but it's already been rounded up. That has already been rounded up. Okay, so that's correct. Plus 1 should also be correct. Gives me 1 byte. Yeah. Right, let's try it with E bytes. So all the way up to the end here. It's printing out a lot more dots than it really needs, though. That's odd. I'm trying to get this section of the hex values working first. Oh, that's taking a while. Why is that taking a while? Is that the build service going funny? Could be. Let's kill it and start that job again. Of course, it could be broken. It could be that that's actually, oh no, it did do it. And that looked okay. Right, let's go back to here and just do, so print out plus 1, because I want to see what happens there. So that printed out the 1 byte, but it's printed out 1, 2, 3, 4, 5 bytes there, which is odd. So let's have a see what we've got here. When it comes to doing this bit, I think that should be as greater than or equal to data read. If we read nothing, we shouldn't be printing things. That's quite cool. That's better. It's only printing out 1 word. I mean, strictly it should probably only print out 1 byte, but I'm not going to worry about that. Actually, I could worry about that, couldn't I? I could do words read. Do this bit with words read. and the other one with as data read, because both of those should be valid. I think that would work. Let me just see. Ooh. Try that. Only one dot. Cool. So let's see what we get when we do a full 10. Does it actually do 1 0? Sorry, not 10. Yeah, that has broken. Well, bother. And that's because words read equals data read. There we go. That's why. Right. Back to here. Okay, and now let's try the actual test we were trying to do, which is 1005 plus 13. Oh, it's still printing out my zeros here. That should be data read. I was using an uninitialized value. In fact, it even told me right there that I was using it. Now it's gone, so that's good. And we're still printing out the value. So this one catches the left side where we're not printing things. This one, if the offset plus the data width, if the end section is outside the bounds, you see the flickering now. Okay, that's interesting. Give me a second. Let me just turn off the effect on that. I think it's just a filter I turn off. There we go. Right, and we'll bring it back to here. Right, with that turned off, let me know if we still get the flickering. If we still get the flickering, then it means it's not related to the bordering, but down to the downstream keyer. Cables. The cable could be the issue, but it seems to be smooth here. But then I've not been staring at it, so it's possible that that might be something that I've not got. Yeah. Let's have a see if this fixes it. If it doesn't fix it, then I'll have to look at something else. I might need to move the cable to a different port. Currently it's plugged into the laptop, which is not ideal. Happy, right? Right, so we're here. If we're here, this is at offset 4. Offset 4 plus the data width, which is 4, is greater than gap plus words read. Gap is 0, words read is going to be 4. So it's not going to be greater than 4. So it should print it. And then when we're here, offset is 8, gap is 0. Hang on, shouldn't it be the start of this block is outside the things we've read? It should be the start of the block. I think that it's not the end of the block we need to care about, because the start is the one that matters. Oh. I feel very dim here. This is not. I'm not reasoning this to the right place. Data red is 8, gap is 0. So when we are sitting here, we have an offset of 8 and a gap of 0 and a words read of 8 as well. And that should be, it is greater than or equal to that. -1. We should be just rounding up, not. Yeah, just rounding up, not rounding up to with a terminator. Okay. That's doing the right thing. So 0 plus 1 . Yes. 1 plus 1. That's not right. That's not right at all. That's gap in bytes, isn't it? Maybe I should have a words gap as well. Maybe there should be a words gap. A word here is the rounded down size. Flickering now. Okay. So that's not good. All right, I'm going to leave everything the same for now, and I'll probably just remove the downstream keyer and see if we can get rid of that. It's a pity because the downstream keyer really made this a lot better management-wise. Basically, it means that I can say, after you've done the entire frame, put this over the top of it. But if that is causing it to flicker, then it's no good. So that's a pity. We're learning things. We're learning things. Yeah, we'll see whether it fixes it next week. Because if I try redoing it now, I'm going to end up with spending 10 minutes just tinkering with the rendering, rather than 2 hours tinkering with the I can't get this buffer working, which feels a bit stupid, but there you go. Yes, I'm going to put words gap here. Words gap. Clear off that. Words gap. And off we go again. Ooh, you know what I could do? I could use my brain here. Memory 8000 plus 1. 8000 plus 1. 8001 plus 1. And 8005 plus 13. Just do those once, see what happens. We can compare them all in one go. Oh, yeah, you actually need to give it commands, not an error. That's better. Right. So 8001 plus 1 appears to have skipped a bit here. Words read equals and we've also got words gap as well. And I know what I did wrong. I forgot to build it. Ooh, oh dear. 223. Yeah, Mr. Sonical on there. Too much time with Python. And that should be a memory there. That one printed nothing. This one printed the right thing, it looks like, sorta. Left thread is not equal to red. Yeah, okay, well, we'll look into the zeroing of that later. So, this case here, words gap of 0, to read is 1. We read 1 word. So offset is 0, words gap is 0, words read is 4. And offset is less than gap. It should be words gap there. There we go. So we treat the word section that's dumping things as word calculations and the byte section in byte calculations, and that should give us the right sort of results. So now that's coming out right, that's coming out correct. This one is printing, oh hang on, plus 5. Yeah, that's correct actually. Because that's the 0 bit there, 0 byte there, and then this one's coming off, and then this one's coming onto here. That is actually more correct. However, this left side here, we've got these dots coming up at the beginning, which is saying that it's trying to print things when they shouldn't be. So we're probably not using gap for the text printing. So have a look at the text printing section. Oh, it probably is just or offset is less than gap. That's probably all we need on that. I could have just looked at the RISC OS Pyromaniac implementation and seen how it did it, but it's quite a different way of rendering these dumps, so it wasn't as useful. Right, that looks better. 1, 2, 3, 4, 5, 6 things printed there. Is that right? That should be, it should be more than that, surely. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Gap plus data red. So if I'd thought about it in those terms before, I probably would have made this a lot easier, because I could have just like gone, oh, there's a gap of so many words here, there's a gap of so many bytes here. There we go, that looks right. So let's take out our debug code here. Do we have dprintf in this file? We don't. In which case then I'll just comment it out. Actually no, I will pinch it. Reveal in sidebar, veneer please. There we go. Pinch that code. Shove it at the top. And then turn that into a dprintf. There we are, that's better. Yep, I feel happy with that. That's the 3 different commands being used. Cool. Wish I'd thought about doing the different commands on the command line first time round. That would have been a lot easier. Excellent. Ooh, lots of expectation differences. Fix for the star memory alignment of bytes. Actually, of words. Actually, we've only tested the words. When the words are output in star memory, we'll strip the text as well. This now honours the gap at the start due to misaligned text addresses, and at the end for lengths. That took a long time. Good. Make test, do those tests, and we should be able to get through a few of them now. I think this should be a little bit better. It may take a moment or two, but I think we should be a bit better on it. Memory size unaligned. So that one is actually a bug in Pyromaniac. That D shouldn't be there. And again, this is a bug in Pyromaniac. It should have printed this word beforehand, I think. So these are looking good. 20 minus 5 plus 13. Yes, that's correct as well. Ooh, that one's a bit different. Ah, that's because it's not, that one's not meant to be printed, to be done. And this is the bytes version. that's working. The size. Unaligned. Coming out okay. Base unaligned and size unaligned. Negative offset plus size, that was the one with the -5 on it before. Register relative we can't do. Excess parameters, now we know this comes out wrong, but let's stop now. We can just do good work. I'm happy with these ones so far. So we need to turn off the show top bit one. Disable that's a Pyromaniac specific test. And we need to set the differences, update the differences for these now. So all of these ones are star memory, memory size unaligned, all of those ones. All right, let's go and rename those files. Cool. Move expect / pi modules. Oops, no. Test data. No. Expect / oh, debugger, yes, no, it's not got that star memory. So all of the ones that have got star memory underscore are now correct, I think. Remind me how you do this. Rename -f, that's how you do it. And it's expect / debugger star memory underscore. Star. Okay. The excess one we haven't actually fixed yet. Negative offset, size and top bit set. We also fixed the star memory Bs as well. Star memory underscore B underscore. Are there any of those? Apparently we didn't have any of those, or maybe I already fixed them. Maybe it was just automatic fixed. Oh, they were already okay, weren't they? They were already okay. So I just want to reset this file back to being its original thing because we haven't fixed that yet. And then we can commit this with an amend because that's all now sorted. Oh, top bit set isn't run at all, so let's just delete that one. We don't care about that file. Okay, and that gets us our tests for those fixed as well. All right, run the tests. Oh, it's nice when there are tests that I can actually run and it tells me whether things work or not, or at least haven't changed. work may be a little bit of an overstatement on some of these, maybe. I do keep thinking there must be a faster way to be able to get these things to run on the remote system. I'm also not sure. I mean, I could probably preload some of the test runs and things, but it's complicated. If I was doing this commercially, I'd be definitely thinking about how to do it faster to make other people's lives a little bit easier, but I haven't really had the time to do that myself. This is what we like to see, nice little row of OKs. Come on. Negative offset plus size. I remember listening to one of the podcasts by somebody I respect quite a lot, and they're said something like, "Oh yes, we've got to. If you can keep your tests down to under 8 seconds, then you're doing really well." Yes, under 8 seconds would be great, but I'm on much more than that just for one individual test, never mind the whole suite. Okay, so that's interesting. That's trimmed down the word. I can make that expanded, and that'll fix that one. Come on. I think it might have stalled now. Right, let's stop it on that. We'll have a look at the star memory A ones in a little bit. Okay, so excess parameters next. So this one here, star memory, is it in the veneer? Pass memory parameters, cannot pass. Hi Andrew. So how do we check pass memory params? Pass memory params. Is that in here or is it in one of the other files? I think it's in CLI parser. Yeah, memory structure to fill in. So all we do is we just read the parameters, and then we want to know that the end, that where we've got to, is a terminator. What did we do here? We passed through to a value, and args is assigned there. And then what do we do with args? We do nothing with it. So should we return it? Memory params. What does memory params actually contain? Is that something we can pass it back in? Memory params. It's just the base and the end. So really this should be a output parameter here. So const char, oops, that wasn't right. Const char star star alt p, end p, in fact, would be better, wouldn't it? Where to store the end of the parameters. Reached. Okay, and at the end of the, if everything is invalid, if np not equal to null, start np equals args. And I'm going to have to change every single one of the places where this is used, which will probably be quite a few. This needs to go into the header. Yeah, there we are. And the easiest way to do this is just to build it and see what happens. Oh, just delete all the files and start again. Oh, rebuild. Yeah, lots of failures in veneer. Do I just want to start arg string not is greater than us, greater than equal to space? It's not a control terminated thing. Report an error. Probably want to put that on the next one as well. String and that one. And hopefully, oh, except those are the wrong message, aren't they? Dump I, star memory I, it should be there. Okay. Make build, see if that works. Yep. And then we should be able to run the memory A tests. Oh, that wasn't memory A I was testing, was it? It was excess. Ooh, oh dear, no, that's not good. What? Right, what do we do? So that's my read the value. Apparently 0. That's probably what I need, because it also returns null if we couldn't pass all of the string. Which would be the case if you'd only supplied some of the parameters. That's bad. No, didn't build it. I've got a bunch of things that are not used in there. Oh, that's probably because they're parts of the Debugger Plus implementation. There we go. The only difference now is this, which is nice. We make that happen. In both cases, that's interesting. We should just be putting it out as a longer thing. So memory, memory. Hey. We put in 08 in these. Root byte 02 for that one, and 08 for this one. Half word would be 04, and 08 for the address. Of course, these 08s will actually be all wrong when it comes to running things in 64-bit, if we actually have a 64-bit address space, which we don't at the moment, but that will become a whole other set of problems to look into. Right, getting some passing now, this is better. Much nicer. So it looks like we're probably going to be still doing this, updating these tests next week. I was hoping I'd get through them all today, but I spent so long on that star memory. Extra parameter foo supplied at the end of memory A. Okay, we can identify that, I think. Pass data width. Virtual value. If arg string not equal to null and arg string star arg string is greater than space, then you supplied too much. No, don't need to braces there, let's do that. So let's build that and then just run that one command. I think we can just do, does that work? Yeah. No, that didn't work. It's still saying extra parameters supplied. It's not recognizing that extra parameter. I did build it, didn't I? I did. This is memory A. Greater than or equal to. Off by 1 again. Bad syntax for, yeah, it's giving me an error. That's all that matters at the moment. Cool. So if I go and have a quick look at that. Tests, debugger, pyro. Where's the excess parameters? So we've got a special expectation here that's for the excess. And I think the easiest thing to do here is just to go, yeah, we'll report that as any error is a good error. So star memory A excess. There's the thing. So we want some replacements for that. Is it replacements? Replace. Expect star memory A excess replacements. Come on, placements. There we go, and then we just create that file. without pi modules in it. S/error : so anything that's got error in there can just be like that, which will give me a message that will still be correct. Okay, and probably the other one that's got the excess as well. Well, actually, I'd probably just do not start, star. Can't spell. I'll just call that star memory excess replacements. Move that to there. And that one wants to be applied to the other excess replacements as well, which was somewhere up here. Excess parameters, there we go. Now, run any of the commands that have got excess in them. That's my new error message, and it looks good. Another one. That looks good too. Ooh, there's memory I1 as well. Might need to do that as well. Star memory. It recognised it was bad star memory syntax, so that's good as well. Excess. Excess. Oh, that was the one. There we go, put that in there. And then we can do the renames of anything that has got the word star excess. And just rerun the tests. Sorry, somebody just spotted that Spanner says, we've been doing the same thing for 35 years. I'm like, yes, that's a long time. Yes. It's an old operating system, and we're also old. Not very old, just a little bit old. Little bit. This one's going to fail because I hadn't run it previously. It's taking its time though. Sometimes the build service just seems to stall, and I'm not sure why. Never seems to happen when I do it through CI, only when I do it from home, which is odd. I don't quite understand that. Let's rerun that and just see if it fixes itself. Either that or a broken command. Yay, that looks good. Right, rename that one as well. So, yeah, what we fixed then? We fixed excess parameters. Yes, it's just fixing the excess parameters and their expectations. Oh, that one didn't. Disable no input support. Register. No input support, it's there. Oh, the non-pyro file has been checked in. I'm a little confused by that. That shouldn't have been checked in. I'm just going to, I'll worry about it again later. Fix for excess parameters not being recognized. Star memory. Refer to it like that, in fact. The star memory family of commands now recognize access parameters and report an error. Thank you very much. Push that. Okay. Now, tests. We've done star memory A. Let's try some star memory I ones and see what they look like. This is where I was talking about before. So this is where we've got difference. We're outputting address, word, text, and then mnemonics. Whereas in the RISC OS Pyromaniac, I'm doing it that way around. So what I'm going to do is I'm going to run RPCMU and see what RPCMU does, because presumably I want to try and keep things as close to what RPCMU does. The easiest way to do this is to just pull it up here. There we go. Oh, nice and laggy. Star memory 38, 1, 2, 3, 4, 5. All right, so it's doing the address, then a text string, and then a value, not the other way around. So I guess that's what we'll do. We'll match the two up to make them the same. Which probably isn't that hard, actually. I imagine it's just a case of swapping around when it prints things. So let's give that a whirl in here. I should have stopped that run. Yeah, there we go. It printed a lot of things. But oh yeah, disassemble flags isn't supported. Maybe I should just mark that as not supported. I'll look at it later. Registered relatives, I don't know about that. Okay. So this is on the disassemble stuff. I think that's what the function's called, disassemble stuff. Yep. Right. Now, what we're doing is ADRA word text. What we should be doing is text word, which not the end of the world. We can just swap it around. So if we look here, it should be text then word. So, hang on. Yeah, so this bit here wants to go here. I think that's all it needs. And we can check this by having that as the command we'll use. Make build. All the way back to the beginning. There. And then we should get it the right way round. Hopefully. Yeah, so this time we've got address, text, and then values, which looks good. So let's basic trans is there. Oh, fair enough. Make tests for memory I. Utility module address, come on. So it's going to be quite different because it's going to end up with things. Ah, right, this is better because we're at least looking at like the same type of strings. We've got comments on the end, fair enough, we can strip those. It's not the end of the world. Top bit set characters still being output. That's an easy fix as well. And then capitalization on both sides. All right, let's attack that because that's quite easy as well. So capitalization is this bit here, capital X's, and the hiding. So hide underscore. Here we go. Hide top bit set is there, and this is in disassemble stuff. So I'll put that here so that we hide the top bit sets there. And we want another X in the address. So that should get most of these differences similar. We're still going to lose this comment on the end here because that's not going to matter. What else? Oh, there's that one there. Register relative. I thought I disabled that. I was sure I disabled that. Hyphen pyro. Register relative. No, it's not disabled. Disable. No input support. There we go. And whilst we're at it, let's disable the no debugger plus support there. Okay, let's build it. Oh. And make some tests. So we should be just seeing differences in the comments on the right hand side. That should be the only thing that's coming out differently now, if we're lucky. Capitalization here. Oh, that's interesting. That's put an H and an L there. What? Oh, I think that's a difference in, yeah, there's a difference in the data that's in memory. So actually that's not really a difference, I don't think. In fact, it's probably a difference caused by, no, I don't know where that is actually. I'm not sure. It looks like there's different modules present at the start of memory. One's using basic trans and one's got utility. Interesting. I wonder why that is. I'm not going to worry about it too much. Not a big deal. I might just need to change how the remote system runs basic trans. That's probably all it is. This one here, again, similar. Case is different. Fair enough. Access parameters has worked. And this one for the debugger thumb code has not worked, but I've got that code lying around. So if I just move // actually, have I even got the code in the binary directory? It's not in. Test, say S. No, I really want to copy the code from Pyromaniac. So let us compare dot against // Oh no. Projects RISC OS, not RISC OS, sorry, Pyromaniac there. Oop, thank you. Maniac / test code /s/debugger. And I'll just do all the test code. And we can copy across the debugger thumb source code. Debugger thumb code. Copy that across. And that literally just looks like it's a bunch of values that are just set up so that they look like instructions that we can disassemble. Nice and easy. And whilst we're at it, we may as well copy across the bin as well, because then we get exactly the same thing. Copy across. Thank you very much. Oh, yeah, right. And then make test code. Make. Yeah, so it's actually giving it a file type here. That's fine, I can allow that. Right, bin, I'll probably want to just remove the one that we just put there, because that's not nice. Oh. Add s/debugger thumb code and bin thumb code. There. So now when we run our memory eye tests, hopefully, well, we'll get all the differences for the environment that we're not using, but I could probably just accept those as differences, couldn't I? Because they're not important. And the differences are on the build server. Oh, unaligned. I think we just round off the unaligned ones. Unaligned is a bit weird. Yes, I think we're broken on the unaligned ones. Cool, but the other one worked fine. No, it didn't. No, it said bin debugger thumb code not found. Didn't we just put that there? I swear I just put that there. I wonder if yeah, that's why. If we want to use it, we have to actually specify it explicitly. And I think I'm going to accept the changes on utility module and yeah, those ones, not the unaligned one though. So if we just do rename start memory eye, what we got? So all the ones for utility module. Well, that one can go, yes. What other ones did we have? Utility module, explicit arm. What was explicit arm? What's it actually saying that? Color's not relevant. Unlines didn't work. Ah, explicit arm means we're explicitly saying we want to run ARM code. Yeah. That one as well. And then the other ones are unaligned is broken, and so is the thumb code. Let's go give this a whirl. Right. And with this, I think we'll call this a day on this. Once we've got these built, I'll just commit them. And they're all on the test branch add test code in the Gerph /RISC OS disassembler C repository, which is, let me just oh, sorry, Debugger C, sorry, I apologise. It's this one. This is the repo. Yeah, so that one we know is broken. Thumb code. Should be giving me an OK. Should give me an OK, I think. I hope it gives me an OK. It didn't. Oh, what do we get wrong then? Oh, interesting. So slightly different uses of things. SWI call that comes out differently. Yeah, fair enough. And then, oh, just we've got the hashes in here, and the slightly different alignment there. Okay, so there's a few things there that are different. Same goes with this. It's LDR 197, slightly different address format, but we can expect those. It's not a big deal. Okay, I'm not feeling too bad. So the difference here is actually semantic, really. So in thumb, all the move and arithmetic instructions are implicitly setting the flags, if I understand correctly, if I'm rightly. At least I think they are. Those ones haven't included it. Yeah, so in Pyromaniac with Capstone, it's actually told us that those are adds. I wonder if the add S setting flags. I wonder if the add actually is setting flags, because the add hasn't been noted as that. That's odd. But yeah, that's what the differences are there. Old style UAL thing, yeah, the unified assembly language formats. So I'm happy with leaving that one as having differences in it. We can have a look at that another time. But the others are good. So let's commit that. Update the star memory I output to be closer to expectations. Expectations from discuss Maniac and compared to classic. Thumb code still has some differences, and the unaligned star memory I doesn't align itself. Push that and build both the 32-bit and the 64-bit versions. Oh, what? Why is that not? Isn't that how we build things? Oh, you've got to give it the file name. Mine is a makefile module. And yeah, there we go. So I'll build both versions, and then we can go and update it in the RISC OS status repo. Hopefully, the 64-bit version will just build, and I won't have broken things. I might have done. Might have got it very broken. Come on. Oh, this is interesting. Why are we doing that? -01 and -OS. Oh, because I made changes. So you remember we discussed last week. Last week? Yes, last week. We talked about the changes that were needed when we optimize for size. So I have added new switches to the makefile system. So you can say optimize equals, and then say, either a number, I think you can say a number, or you can say max, or you can say 1, 2, or 3. Or so for size, I think is the other one. And it'll tell it to do that. So the default is -0.01, just simple optimizations. And it decides whether you're building for Norcroft or whether for GCC, which one of those it's going to use. And so then it switches that off. But because we've explicitly specified -OS, it's now got two conflicting things here. That doesn't make a difference, I don't think. We'll just have a look at the sizes of them. Yeah, that's probably used 01 actually. Let's just change things so that we actually, where's the makefile gone? Makefile module. If I go and tweak this, so we put optimize equals max, and then just rebuild things. RMO. What we should get now. Actually, no, I didn't want max. I wanted for size, didn't I? Oh, no, maybe it's not. It's written O time here, so that's probably not the right one. It should be O space. I don't remember whether it's time or space. Oh, no. Oh dear, that was an interesting error message. Let's just start again. Clean. Oh, time. Oh dear, maybe it's not working. And here it's gone to 01. Oh, that's frustrating. I thought that was the way you... Oh, hang on. Is that because you put it beforehand? Less amu files / underscore config. I think it's in config. Optimize for size gives us O space and OZ. Right. OZ. Is it OZ or should it be OS? We were using OS before. I'm going to have to look that one up and check, but let's go for size anyway. Size, there we are. Delete everything, rebuild it. Right, that's better. It's doing O space now. And in GCC, OZ. What is the difference between OS and OZ in GCC? OS is for code size, is more aggressive. Oh, so that actually may make it less. Okay. S is size conscious, similar to O2, whereas Z is more extremely size focused. We'll use OZ then. Aggressive. Fair enough. It does say a significant decrease in runtime performance. I don't really want a significant decrease. Maybe I should tweak that so that it's just OS rather than OZ. Yeah, I might go and change the defaults on that because I don't really want it to be much slower. If we have a look at the sizes now, that's not much better. That's disappointing. Oh well, not going to worry. Let's go and copy them off. Let's copy our move RM into the status area and go over to the status area. Poll, make sure we've got all the latest changes. Auto stash. Yep. So, oh, I also want to update the README downside, the status file rather. Debugger. Decodes ARM, Thumb, and ARC64. There's nothing new to say there, so actually that's just fine. Debugger version from today's live coding. Latest debugger has closer output to the classic version and handles unaligned addresses much better than before. There we go. And we can push that. Right, so today we've dealt with quite a few of the tests to make sure that they're doing the right thing. They now produce some pretty good, okay results. So we're actually to run make tests here. It should now start in the test code directory. Make tests. Oh, I forgot to. I've moved it out of the way. Just rebuild it. There we go. This will take just a moment. Yeah, there we are. And then I can run the tests. So what we've done today is looked at some of the test code that made work yesterday, last week rather. We've looked at harmonizing some of the output and adding in some replacements. Small difference there because they're different in addresses. Not going to worry about that. I can probably do replacements to fix that one later. We've managed to make unaligned addresses and unaligned lengths work significantly better in the star dumps and the star memories. So that should be good. And what else did we do? Memory I now prints things out with the hex values properly, and we're using capitalization everywhere. And that's about it. I spent a lot of time trying to get the star memory output working properly, but once that was working, we had a whole bunch of tests starting to work. All these ones here are now starting to work, so that's gone really well. So we've still got a number that are broken, so not broken, sorry, giving us slightly different output. And we've got the SWI tests to check on to make sure that the actual SWI output is working properly. But I think we're doing quite well. I had hoped that this time we would get all of the tests fixed, but clearly that just took a little bit longer than I expected. Not going to worry. Everything always takes longer than you think. So with that in mind, we have copied everything over to the RISC OS status repository, and I'll quickly go and show that in case anybody's really been paying attention. So that's not it. RISC OS 64 status. So this is the status repo that's showing what we've actually got working, and most of the actual status information is in current development status. And this has got a big list of all of the ROM components and what's been done. So as of a few days ago, I finished implementing all of the conversion routines. That's now marked as complete. And we've got Debugger here marked as functional. It goes ARM, Thumb, and ARC64. So that's all working well. We've also got a different view on the progress, which is shown here in the progress list, which shows us for each phase of the development how things are going. And as you can see, Debugger is now up at functional. I think we can probably move it up to completed shortly, because I think we're pretty solid now. It's also strictly, we've tested it all by hand as well, so we could probably move it into the state tested. But we are at the point where everything was expected to be. There are still a number of components that I'd like to get working, which I haven't done yet, but there's a lot here that are complete to the point of being functional, which is where I wanted them to be. The next phase along, when that's finished, has a whole load of modules to be dealt with. That's going to take a little while, obviously, but we can have a look at that later. I'm expecting that I will move on to looking at one of these other ones, probably actually look at the template parsing, because that's relatively interesting and easy. Well, interesting, vaguely interesting. Mostly gives you just some text output, but we can get it working anyway. Yeah, so that's where we're up to. I will post a update on the RISC OS Open forums for what we did today, and all being well, we'll come back next week. Hopefully I won't be too exhausted next week, but yeah. And thank you to everybody who's come along today. It's been quite a few people here. I'm quite pleased that we've had some new people. I hope it's been interesting for you. I have left the output running for the tests, and you can see there's a few here that just like hasn't got the right files. This is the thumb code not working and so on. But many of the others are just doing their job. Hopefully, I'll just wait for this to finish because I think there's only a couple more things for it to do. Maybe I won't wait for it. No, that hasn't printed anything out. Maybe we should print something out. Maybe that's a... Oh no, got 124. 124 is... I timed out. I took too long doing it. So that probably is a bug. We need to have a look at that. Otherwise, yeah, I'm going to call it a day there. Thank you very much for watching. We'll see you all maybe next week. Bye. Yeah, I will stop those now. Bye.